Welcome back to Calculus. I'm going to try out a new problem that I just made up, so hopefully this works. We'll see. You should see on the screen right now the 4 lines that we're going to look at them graphed, and then we're going to revolve this around y equals 3. So this is kind of a deliberately challenging one to kind of talk through some stuff. There's some other videos I've posted, some other ones that you can check out too. But let's see what happens with this. Y equals sine x plus 1. That's the sine curve shifted up 1. So now its equilibrium is going to be at 1 instead of 0. Now the range will go from 0 to 2. So at pi, be a halfway mark, and at halfway there, pi over 2, it will be at a maximum, which in this case will be 2, and at 3 pi over 2 will be at a minimum, which is going to be 0. And then at 2 pi, it's back to equilibrium. It will look like this. Okay. Then there's let's get the other lines on here. Then you have y equals 0, which is just going to darken the x-axis. You have x equals 0, which is this, and x equals 2 pi. So there's our region. It was looking so nice until I did that orange. So this is the region that we're going to rotate around we're going to rotate around this, y equals 3. So it's going to create a really odd shape. It'll be smooth on the outside, but it will be this sine kind of curve inside. So if I want to find the volume of this, we need to draw a representative rectangle. So let's just put one here. It's going to be perpendicular to our axis of revolution. It's tall and narrow, so it has a tiny x, so put a dx there. So the 3 things I want to see on your graph are the arrow, the representative rectangle, and the dx. Of course, labels and the graph itself, those are 3 things that you might be tempted to leave off. Okay, the volume, I'm going to try to get this all on this page so we can see everything. The volume is going to be, always put pi first. The interval, what are our bounds going to be? Well, this is going to be dx, right? It's going to be dx because we have dx here. So they're going to be x bounds. And also I like to think of the slices. Remember the slicing idea, the color that will stand out. You have your slices like this. As you're chopping this up, those are the slices, so they're lined up in the x position. The best way to think of it is just it's dx, so they're x bounds. So what are the x bounds? Well, simply 0 to 2 pi. 0 is the left edge of this region, 2 pi is the right edge. Okay, what's next? Well, then we need to do our radius, and we're going to need washer in this one. So the outer edge, let's use blue here. How far is this outer edge from the axis of revolution? Let's draw an arrow, and you see that it's 3 there. If you did a representative rectangle over here, then, I don't want to draw through my graph, let's say you did one over here, it is still the same. It's 3. It's a constant. The outer edge lies along the x-axis. So that's going to make this just 3 squared. That works out pretty nice. Minus the inner edge. Well, the inner edge, what color could I use here? the inner edge here, when measured like that, it looks like it's about 1. But if I use this representative rectangle, it's larger. It's changing. It is, one of them has to be changing. It's not going to be a constant, right? So it's changing. How can we describe it? Is it just the y-coordinate? No, it's not, right? Because here it has a, here the y-coordinate is, and this lower region is smaller than this one. Yet that arrow is longer. This arrow is longer than this arrow. So it's not the y-coordinate, but it is going to be 3 minus the y-coordinate. What is the y-coordinate? That's the y-coordinate. So it's going to be 3 minus sine x plus 1. That's our inner radius. And I can simplify that to 3 minus sine x minus 1, or 2 minus sine x. The simplified form doesn't make quite as much sense, but it's going to fit better in my little space there. So hopefully that makes sense. 3 minus sine x plus 1. So if you're up on this is a balcony, you're hanging out on the 3rd floor, and you're trying to find out how far below someone is on the 2nd floor, or 1.5 floor, or 0.7 floor, you would do 3 minus their floor number. So if they're on the 1st floor, 3 minus 1 means they're 2 floors below you. So it's 3 minus their height, which is described with sine x plus 1. So now I'm going to use this simplified form and put in 2 minus sine x. Don't forget to square it. And that's it. I don't have a calculator on me to figure out what this is going to be, but you can plug it in and get an answer. So hopefully that helped a little bit. Sorry for the mess. Talk to you later.
Made with Doodlecast Pro.